All right, so the next section we're going to talk about is about this thing called piecewise functions. And piecewise functions are nothing more than kind of graphing two graphs on one graph. So let's take a look at this very first one. You have two functions. You have f of x equals x squared, and you have f of x equals x plus 2. But these have what are called domain restrictions on them. So let's take a look at what that means. Let's first graph f of x equals x squared, and let's ignore this domain restriction for a moment. So I know if I did an xy table, I would be at 0, 0, right? I would be at 1, 1, so I went over 1, up 1. I'm just using my quadratic pattern to graph this. I would go over 2, up 4, 1, 2, 3, 4. And I could go over 3, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. But I'm off my graph, so I'm not going to bother. And so if I graph this function, it would look like this. Kind of going back to algebra 2 when you graphed quadratics. But this now has a restriction that says x has to be greater than or equal to negative 1. Well, here's negative 1, so my graph can only be on this side. It can't be less than negative 1. So I have to basically erase this part of the graph. Now it says less than or equal to, so negative 1 is still part of my graph, so I'm going to keep that in as a colored in circle. Now on the very same graph, I'm going to graph this next function. This is a linear function, x plus 2. So I'm going to start at my y-intercept of 2. Maybe I'll do this in a different color. Y-intercept of 2. And my slope is 1, so I can go over 1, up 1, or over, down, negative 1. But I have my restriction here that x has to be less than or equal to negative 1. So I can't have anything that is past this point. So from here, if I go over 1, down 1, this would be my point. So I basically have an open circle here. You'd have to ignore this point. An open circle here, and I'd go over 1, down 1, over 1, down 1, over 1, down 1. And I'd have my function that looks like this. The next thing we have to find out is the function continuous or discontinuous. Continuous means that there are no holes, or there's no restriction on my x values, and discontinuous means that there is a hole. All right, so a hole would be if I had an open circle somewhere. Well, I have an open circle right here, but it got colored in when I went to this function. So this here would be a continuous function, because there's no value here that x can't be. X can be anything. All right, and now it says evaluate f of negative 1. So what you have to do here is you have to say, all right, where is negative 1 valid? So if I put negative 1 in here, negative 1 is greater than or equal to negative 1. Well, that's true. If I put in negative 1 here, negative 1 is less than negative 1. That's not true. So it's true for this function. So that means this is the function I'm going to use. So I would say f of negative 1, I'm going to put negative 1 in for x. I have to square it, and I'll get out 1. So f of negative 1 equals 1. So basically, you're going to choose which function is true based on the restrictions given. I'm going to stop here and continue on the next one because I feel this is a little blurry.